Alright, for 7.5 we have the sum and difference formulas for two angles on the unit circle, or just two angles in general. Here we go. We're going to get right into it. The first theorem here is something that you should probably just memorize. The proof for it is also interesting, and I encourage you to look at that. But once you have this memorized, you can then use these formulas for cosine and sine to find the sum of any two angles on a unit, on a unit circle is typically where we're looking, but yeah. So here we have the cosine of angle of alpha plus beta. Notice the pattern here. You have cosine alpha, cosine beta, with the opposite sign of where we started. So we started with, if we're adding two angles together, then the sign switches with the cosine. All right, and then you have sine of alpha, sine of beta. It'll always be alpha, beta, so that's kind of a cool little pattern. Then for cosine of alpha minus beta, same exact thing. The only thing that's different is when we're subtracting two angles from each other, this is going to be addition. So here we go. Let's look at example 1. We have how does this all work? We have the cosine of 105 degrees. Well, what I want you to think about with example 1 is, because 105 degrees is not a very nice place on the unit circle. Okay, so it's not a place that we can just identify like what's going on there very easily. So what I want to do is I want to break that up into two pieces. So that's the same exact thing as 60 plus 45. Okay, those two places on the unit circle, however, happen to be nice places, right? So what I'm going to do is I'm just going to start with my sum formula, which you should refer to your notes for a little while, and then you should just be comfortable doing this. But call this alpha, call this beta. Okay, so we have the cosine of 60 degrees times the cosine of 45 degrees minus the sine of 60 degrees times the sine of 45 degrees. All right, when you do that out, the cosine of 60 degrees is, so you know that's, since we're at 60 degrees, it's either going to be a half or it's going to be root 3 over 2. Since we're talking about the x value at 60 degrees, it's going to be the smaller of the two, so that's 1/2. So we have 1/2 times, and then 45 degrees is always nice because it's the same. Okay, so root 2 over 2 minus, now we'll have the root 3 over 2, right, the sine of 60 degrees, times root 2 over 2. Okay, a little bit of multiplication here. You get root 2 over 4 minus root 6 over 4. That's probably an okay answer, or you can just take a fourth out of that and write it as root 2 minus root 6. Either way is fine. Okay. Then for example 2, it says find the exact value of the cosine of 5 pi over 12. Well, that can be broken up. I know that, so one thing that you could do is you could convert that. So you might want to do that. So if you wanted to convert that to degrees, you would have 180 over pi, right? Okay, and so the pi's can cancel out here. And then doing some quick work with a calculator here, you can see that 5 pi over 12 is equal to, we do 5 times 180 divided by 12. Where's my calculator? There it is. 5 times 180 equals, divided by 12 equals 75 degrees. All right, so for 75 degrees, we can think of that in terms of 45 degrees and 30 degrees. Those are nice places on the unit circle. So let's do that. So let's rewrite this as the cosine of 45 plus 30. If we did that, it would be cosine 45, cosine 30, minus, since we're doing the sum here, and it'd be sine of 45, sine of 30. All right, so when we do that, cosine of 45 degrees is simply root 2 over 2. Cosine of 30 degrees would be root 3 over 2. And then the sine of 45 degrees is root 2 over 2, and the sine of 30 degrees is 1/2. So this is going to be very similar to the last one. When we do this out, we get root 6 over 4 minus root 2 over 4. Or you could say this is 1/4 of root 6, root 6 minus root 2. Okay, And again, I'm just getting these values here. I'm getting from my unit circle values that I know well by now. There's an identity here in the middle. Basically, what this is saying is if you have the cosine of pi over 2 minus theta, that's equal to sine. The reason for that is if you look at the cosine graph and you look at the sine graph, you'll notice that sine and cosine are just, they're like the cosine function and the sine function are just shifts of each other. So cosine is equal to 90 degrees, you know, minus whatever your theta is. Sorry, the sine is equal to the cosine of 90 degrees minus whatever your theta is, because the whole thing is shifted by 90 degrees. So that's something that you could just see if you look at the sine graph and the cosine graph. So let's look at the next theorem for sine. Sine is essentially the same as the cosine in that it's an alpha beta pattern, alpha beta, alpha beta, alpha beta, alpha beta. But what I want you to notice here is when you're adding the sine of two thetas, the sign stays the same, right? So when you're adding, it's addition. When you're subtracting, it's subtraction. That's different from the cosine. And then it's a sine, cosine, cosine, sine pattern. Sine, cosine, cosine, sine for both of these. Okay, so that's the difference between the two. Let's look at one of these here. Looks like they've done this for us, but that's okay. Let's just look at it. So the sine of pi over 12. Pi over 12 is the equivalent of, I believe, 15 degrees. Okay, so if we were going to do 15 degrees, that's the same thing as, well, we can do a difference formula there. That would be the same thing as 45 minus 30. Okay, so we could say the sine of 45 minus 30. So we're doing the difference sign formula. Let me just zoom in here for you guys. Okay, so the sine of 45 degrees, we know that, so we're going to do sine of alpha, which is 45, cosine of beta, which is 30. Okay, and then the sine stays the same, so we're going to subtract. And then we have the cosine of alpha, sine of beta. Okay, so when you do a little bit of multiplication here, you get root 2 over 2 times the cosine of 30 degrees is equal to, since that's the smaller of the two and it's the x value, you're going to get the larger value, which is root 3 over 2 minus root 2 over 2 times sine of 30 would be the other one, which is 1/2. There we go. So when you do this out, you get root 6 over 4 minus root 2 over 4. Okay, and then this just comes out to 1/4 root 6, root 6 minus root 2. Okay, they did it a little bit different here. They kept it in terms, so I converted to degrees. They kept it in radians. If you want to see that method, it's here. But you end up with the same math at the end. And then for example 4, it says, find the exact value of this guy. Well, when I'm looking at that, that's a sine, cosine, cosine, sine formula. It's a sum formula. So if I took a step backwards and saw what we were doing here, this is the same thing as the sine of 75 plus 15, right? And then they broke it up into this long thing. So I'm just kind of working backwards. That's the same thing as the sine of 90 degrees. Well, if the sine of 90 degrees, that's the y value on the unit circle at 90 degrees, we know that that is a 1. So this is equal to 1, and you're done. All right. The last thing that I want to do with you on this video is this one from example 5. Example 5 says, we know that the sine of alpha is equal to 1 over root 2. So I'm going to remind you of a couple things here. First of all, sine is equal to y over r, right? And then we know, we've proven this before, that x squared plus y squared is equal to r squared. Okay, so what I'm going to encourage you to do for things like example 5 when you're given something like this is they're going to give you 2 pieces to the puzzle. You're going to find the third piece, and from that you can find anything that you need to find. Okay, so the y value in this case, the y value is 1. We know that we're between pi over 2, which is 90 degrees, and pi. Okay, so that means that we're in this quadrant here, quadrant 2. Okay, so I know that's where I'm at. That's important. And then I know that my r value is equal to the square root of 2. Okay, because sine is equal to y over r. So what I'm going to do is I'm going to solve for x. So to solve for x here, I'm going to say, okay, x squared plus 1 squared equals root 2 squared. That means that x squared would be equal to, this comes out to 2. 2 minus 1 is just 1. So x is equal to square root of 1, which is just 1. Okay, so our x value here is equal to 1. And that's plus or minus, I should add, because you took the root of it. So we need to figure out which one it is. Since we're in this quadrant over here, the x values over here in quadrant 2 are negative. So this will actually be a negative 1. Okay, so now what they want you to do is they want you to find, these three things. They want you to find what's the cosine of alpha, what's the cosine of beta, what's the cosine of alpha plus beta, and then sine of alpha plus beta. Well, one thing that's an issue here is that we're missing a piece of the problem, which I will fill in here in a second. But for alpha, cosine of alpha, we can definitely find that right now. The cosine of alpha is going to be x over r. Well, in this case, x is negative 1, so it'll be negative 1 over root 2, which they might let you leave like that, but if you want to simplify that, you can multiply it by root 2 over root 2, and you get negative root 2 over 2.